Now that I've created some 3+2 operations and run some basic stock simulations, I'm confident that the tool and holder are clear of the dovetail fixture and any stock. However, I'm missing some machine components, like the table and spindle, that are important to consider before running any multi-axis operations on the machine. So I'll go through how to add those components and make my stock simulation even more accurate for multi-axis operations. In the comments of this design, there's a Dropbox link to a page that contains several folders with HASS machine names. I would run this part on a HASS UMC 750. So I'll open that folder and download both the solid assembly and parasolid files. To add them into Fusion 360, I'll use the upload dialog in the data panel and select both files to upload. Once the upload is complete, I'll double-click and open the machine model. This is a full model of the machine, but since we don't need the full machine design, I'm only concerned with certain portions. It's unlikely that there will be issues with the door, tool probe, enclosure, or X-gantry, so I'll just hide the visibility of those components for now. This leaves me with the C-axis table that spins 360 degrees and the B-axis that tilts to give full 5-axis motion. While the B-axis is fairly large, there's not much room for collision since the C-axis platter can always spin to reorientate the part in a safe position. This leaves the platter and the spindle. My main concern is collision when the table is at a steep angle and the tool is down in the part, bringing the spindle nice and close to the table. To simulate this, I'm going to need to add the table to the model and create a tool holder that represents the spindle. First, I'll use the model to measure the spindle so I can recreate it as a tool holder in the manufacture workspace. I could create a tool holder that includes every little detail, which would be very accurate, but I'm going to round and use the largest diameter for each section, which will both save me time and give slightly larger margins of error. Using the measure tool, I'll note the approximate length and diameter of the lower and upper sections of the spindle. Now that I have the spindle dimensions, I'm left with just the platter of the UMC 750. Although I started with the full machine model, all I really ended up needing is the machine table. There is a folder in CAM samples that contains machine tables, including one for the UMC 750. So rather than following that entire process from full machine model to table, I can just open this design, save as into my current project, and then use the data panel to insert it into my upright design. I'll rotate the table to the correct orientation and move it into the approximate position. Then I'll use a rigid joint to position the center of the dovetail fixture directly above the center of the UMC table. I'll add a Z offset from the riser, which will help adapt the fixture to the table and add some extra clearance between the part and the machine table. There was no riser designed specifically for this dovetail fixture by the manufacturer, so I'll quickly model one up in the context of the fixture and the table by creating a new component called riser. Using basic sketch and extrude commands and adding holes to bolt the riser to the machine table. If there were a standard riser from the vendor, I could insert and join its model the same way I added the table. I'm done adding components to the model. Now I need to create a tool holder to accurately represent the machine spindle. In the manufacture workspace, I'll open up the tool library and edit the tool holders in the document library. I'll add a section to the top of the list to add geometry to the top of the holder and enter the dimensions from where I measured the spindle. I'll repeat this process for the other two tool holders used in this part, so all the tool holders are also accurately represented in the spindle. The last step is reassigning the holders to the tools to update the holder for that tool and ensure my edits make it to the stock simulation. Now I'm ready to regenerate my operations and take a look at the stock simulations with a more accurate representation of what will happen in my machine. Note that the stock simulation mode must be set to standard to simulate any multi-axis toolpaths. One simulation trick is to pause the simulation when it looks a little tight, then click and drag left or right to move the tool forwards and backwards with extra control. This makes it easy to get a good look at the areas where things might get a little too close for comfort. Now that I'm comfortable with the toolpaths on this part and can use the same workflow to get accurate simulation results for multi-axis operations in Fusion 360,